Welcome back, class. This is Unit 8, Lesson 3, solving equations with variables on both sides. So now when we look, there are going to be variables on both sides of the equation. We're still going to be solving for x by getting one variable alone on one side of the sign, of the equal sign. So number 1, use distributive property if necessary. 2, combine like terms if necessary, if they are like. Move one variable by adding its inverse to both sides of the equality. Solve as usual. So first example here, we're going to use the manipulatives to show what it's like when we have variables on both sides of the equation. This equality is written as 3x plus 1, because these represent x's, these represent 1's. 3x plus 1 equals 2x plus 6. So that's what it is over here. And just like we did on our last exam and on the review, we want to have x's on one side and our 1's or constants on the other side. So what we're going to do is we're going to just cancel the same amount per side. So if I want all of them on one side, there are more x's over here. So then I can cancel these two, which then I have to cancel those two. And then my simpler equation is going to be x plus 1 equals 6. That's the simpler equation because now we just have one variable, and this is a one-step equation that we're familiar to. Next, our inverse operation would be to cancel one of those from both sides. So then we would get x equals 5. And I can show that right here. If we do our inverse operation, we would subtract 1 from both sides, so that then we have x by itself, and we see x equals 5. So that's what we're doing. We started with variables on both sides, and we still ended where we found out what x equals. If we substituted it back in, both sides of the equation would be equal. These expressions would be equal to each other. So let's practice now not using manipulatives. So we want our x's on one side, so I'm going to move them to the side with more x's. So I see more x's over here. So since this is a positive 3x, the inverse would be to add a negative 3x or subtract 3x from both sides. Then this difference is 0, and we're left with just a positive 4 equals, we have 5x minus 3x, so that's 2x minus 2. Now I want to get my constants or numbers, my not variables, my integers on the other side. So now, if it's 2x minus 2, I can add 2 to both sides. So 2x equals 2. And then one more step, since this is a product, I'm going to divide both sides by 2. So then x equals 1. Okay, let's look at this side. Same idea. We want to put our variables on one side, and we're going to bring it to the side with more variables. So I see more y's on the right. So since this is a positive 15y, I'm going to subtract 15y from both sides. This then is 0, so we're left with 12 equals 2 plus 35y minus 15y is 20y. So then we can subtract 2 from both sides. That is 0, so we have 10 equals 20y. Again, we can solve for variables other than x, and we can solve for variables that are on both the left and the right side. Now, I'm going to want to divide both sides by 20 to get y by itself. So then we see that we have 1y equals 10 divided by 20. That fraction can be simplified to 10 divided by, we could do 10 times 2. So we see that 10 over 10 is 1, so we're left with half. Again, you can substitute it back in, and you'll see that both sides of the equality are equal. Now we are going to have to use the distributive property. On the left, I'm going to do that first. I'm going to distribute this so that I have 3x plus 3 times 22 is 66 equals 12x plus 30. I don't have any more terms to combine on either side, so now I'm going to solve for x. I'm going to move my x's first. I see more x's on the right, so I'm going to bring them to the right. Minus 3x, that's 0, so 66 equals 9x plus 30. Now I'm going to want to subtract 30 from both sides. So then I have 36 equals 9x. Now that it's a product, the inverse would be to divide both sides by 9. So then I have 4 equals x. Distributive property, and it looks like we might have to combine like terms. So I'm going to distribute first. So I get 3y plus 3 minus 5. I just brought that down. Equals 5y plus 2. I do have some like terms. My constants, so I can combine those. It's a difference, and it's going to be negative since the 5 is bigger, and the difference is 2. Which way am I going to want to move my y's? To the right, since there are more on the right side. You can move them either way, but this will make it easier. So we're going to subtract 3y from both sides. So that we're left with negative 2 equals negative 2, excuse me, that's a positive 2y. 2y plus 2. Subtract 2 from both sides. Negative 4 equals 2y. Now we need to solve for y, so we need to divide both sides by 2. Therefore, y equals negative 2. Okay, so we're doing a mix of a lot of things we've learned previously. Now, we have variables on both sides, and we have to use the distributive property twice. So I'm going to do this one first. So that's 2x minus 2 times 4 is 8, plus, now I'm going to do 3, and distribute that through. 3 times 5x is 15x, minus 3 times 1 is 3. And then on the right, we just have 12x plus 9. Some like terms again. I have a positive 2x and a positive 15x. So when I add those together, I get 17x. Then I have some constants with the same sign. So when I add them together, we add and keep the sign. So that'd be a negative 11. So then we have 12x plus 9. And now, look, I have more x's on the left side. So I'm going to want to move this 12x to the left. So I'm going to subtract 12x from both sides. That's 0, so then we're left with 5x minus 11 equals 9. Solving for x, so we want to add 11 to both sides, because that's the opposite of subtracting 11. 5x equals 20, divide by 5. So we just have x by itself equals 4. Okay, and that's the order in which you're going to want to do these problems. It's kind of a mix of everything we learn, and that's also why it's really important to take our time and practice each step. So I have a couple for you to try. There's a challenge one. You have to distribute, combine some like terms, and then you'll solve for y. Y will equal one number. And if you have any questions, let me know, and thanks for watching. Okay, bye.